Well, the modern ocean moves like a giant conveyor belt, and late in the 20th century, this was described by a number of scientists at Columbia University in New York City. What we found was that ocean water ages as it goes down from the North Atlantic into the South Atlantic, into the Indian Ocean, and then into the Pacific. And so what they discovered was that bottom water is formed and deep water is formed in the Arctic and Antarctic regions. So in the Arctic regions, you end up with deep water forming south of Greenland, and we have bottom water forming around Antarctica. So the big conveyor belt that the scientists were describing had their origins in those regions. If we take it from what the deep water is doing, it starts in the North Atlantic, ends up dropping from the surface down deep. So why does that happen? Well, it happens in the wintertime when sea ice is forming and brine is expelled from the sea ice itself. The sea ice itself is actually fresh. So how do you get fresh water out of salt water? Well, it has to get really cold for one thing. But as it's forming, the salt from the actual seawater in that sort of mushy sea ice is actually being extruded out the bottom. So you end up with this cold, which is dense, very saline water, basically raining down. So that's the origin of this deep water in the North Atlantic. So that ends up forming a flow that ends up moving down the North Atlantic into the South Atlantic, then gets entrained with water moving around Antarctica. Branches of it go out into the deep Indian Ocean basin, and then last of all, that happens in the Pacific Ocean. And the oldest deep water in the Pacific Ocean today is almost 2,000 years old, not quite. And that's in the deep North Pacific. Then it sort of very sort of gradually upwells all around the North Pacific and then moves back. So this is the surface flow now. So it moves back from the Pacific through the Indonesian archipelago, across the Indian Ocean, around South Africa, and then up into the North Atlantic again. And it gets more and more saline as it takes that trip because it gets more and more evolved and evaporated. So the surface Atlantic Ocean basin is the most saline compared to the Indian and Pacific Oceans.
So when you consider the very high heat capacity of water, what this immense volume means is that by changing the temperature of these deep and bottom waters by only a tiny amount, by like 1/100th of a degree, you provide the climate with a mechanism to store vast amounts of excess heat and lock it away from the atmosphere, which is where we live and where we experience excess heat in extreme weather. In this way, the deep oceans can be thought of as a massive heat sink, as somewhat of a thermal regulator for Earth's climate.